Alright, so in this problem, I have 3 to the power of x times 5 to the power of x squared is equal to 15. So now the first thing I'm going to do is divide both sides by 5. So now I have 3 to the power of x times 5 to the power of x squared over 5 is equal to 15 divided by 5, which is 3. Now if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So in this case, 5 is the same thing as 5 to the power of 1, and 5 to the power of x squared over 5 to the power of 1, that's going to equal 5 to the power of x squared minus 1, which is equal to 3. And now I'm going to divide both sides by 3 to the power of x. So then these two cancel out, and 3 to the power of 1 over 3 to the power of x, that's the same thing as 3 to the power of 1 minus x. Now, if I take the log on both sides, I get log 5 to the power of x squared minus 1 is equal to log 3 to the power of 1 minus x. And if I have something in the form log a to the power of b, I can actually move this exponent b to the front. So this can equal b times log a. So in this case, I have x squared minus 1 times log 5 is equal to 1 minus x times log 3. Now, if I divide both sides by log 5, I get x squared minus 1 times log base 5 of 5 is equal to 1 minus x times log base 5 of 3. So if you divide two logarithms, the logarithm that's being divided by, that's going to turn into the base. Now log base of 5, that's obviously equal to 1. So now I have x squared minus 1 is equal to 1 minus x times log base 5 of 3. And now if I subtract 1 minus x times log base 5 of 3 on both sides, these two cancel out, and I get x squared minus 1 minus 1 minus x times log base 5 of 3 is equal to 0. And now x squared minus 1, this is the same thing as x squared minus 1 squared, which is the same thing as x plus 1 times x minus 1. So I have this minus 1 minus x times log base 5 of 3 is equal to 0. And now if I factor out x minus 1, I get x minus 1 times x plus 1 plus log base 5 of 3 is equal to 0. So now this gives me two equations. I have x minus 1 equals 0, meaning x is equal to 1, and I have x plus 1 plus log base 5 of 3 is equal to 0, which means that x is equal to -1 minus log base 5 of 3. So these are my two solutions. Alright, so in this problem, I have x to the power of 4 minus 16 is equal to 0. So what I'm first going to do is I'm going to rewrite x to the power of 4 as x to the power of 2 times 2. And if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 2 times 2, that's going to equal x to the power of 2 to the power of 2. Now I have this minus 16, which is the same thing as 4 to the power of 2, is equal to 0. Now if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is x squared and b is 4. So I have x squared plus 4 times x squared minus 4 is equal to 0. So now this gives me two equations. I have x squared plus 4 is equal to 0, and I have x squared minus 4 is equal to 0. So for x squared minus 4 equals 0, I'm going to write 4 here as 2 squared. So now I have x squared minus 2 squared is equal to 0. Now remember that if we have something in the form a squared minus b squared, this is equal to a plus b times a minus b. And in this case, a is equal to x and b is equal to 2. So I have x plus 2 times x minus 2 is equal to 0. So now this, again, gives me two equations. I have x plus 2 equals 0, and I have x minus 2 equals 0. So for x plus 2 equals 0, x equals negative 2, and for x minus 2 equals 0, x equals positive 2. So these are two solutions of x. Now for x squared plus 4 equals 0, I'm going to subtract 4 on both sides. These two cancel out, and I have x squared is equal to negative 4. Now I'm going to take the square root on both sides. Square root of x squared is x, and the square root of negative 4, that's the same thing as the square root of 4 times the square root of negative 1. The square root of 4 is 2, and if you guys already know, the square root of negative 1 is I. So I have x is equal to positive or negative 2i. So these are another two solutions. Alright, so in this problem, I have x to the power of 6 minus x to the power of 3 is equal to 2. So I'm going to first start by subtracting 2 on both sides. So now I have x to the power of 6 minus x to the power of 3 minus 2 is equal to 0. Now I'm going to write 6 here as 3 times 2. So now I have x to the power of 3 times 2 minus x to the power of 3 minus 2 is equal to 0. Now if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 3 times 2, that's going to equal x to the power of 3 to the power of 2. Now I have this minus x to the power of 3 minus 2 is equal to 0. Now I'm going to let x to the power of 3 equal y. So now I have y squared minus y minus 2 is equal to 0. Now to solve this, I'm actually going to factor this out. So y squared minus y minus 2, this is the same thing as y squared minus 2y plus y minus 2, because negative 2y plus y, that's negative y. And now if I factor out y, I get y times y minus 2 plus 1 times y minus 2 is equal to 0. Now if I factor out y minus 2, I have y minus 2 times y plus 1 is equal to 0. So meaning y is equal to either 2 or negative 1. Now remember how we set x to the power of 3 equal to y. So now I have x to the power of 3 is equal to 2, and I have x to the power of 3 is equal to negative 1. So first off, for x to the power of 3 is equal to negative 1, I'm actually going to start by adding 1 on both sides, so I have x to the power of 3 plus 1 is equal to 0. Now this is the same thing as x plus 1 times x squared minus x plus 1 is equal to 0. And this gives me two equations. I have x plus 1 is equal to 0, meaning x is equal to negative 1, so this is one solution of x. And I have x squared minus x plus 1 is equal to 0. And if you actually go ahead and plug this into the quadratic formula, I'm actually not going to waste your time, guys' time and do that. You should get 1 plus or minus the square root of the square root of 3i over 2. So these are two more solutions of x. Now, right here, I have x to the power of 3 equals 2. This is pretty straightforward. All I have to do is take the cube root on both sides. So I have the cube root of x to the power of 3 is equal to the cube root of 2. The cube root of x to the power of 3 is x, and the cube root of 2, that's simply, we just keep it in that form. So I have x is equal to the cube root of 2. Alright, so in this video, I'm going to solve the problem 2 to the power of 22 minus 1. So, to solve this, what I'm first going to do is rewrite this as 2 to the power of 11 times 2 minus 1. Now, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 2 to the power of 11 times 2 is equal to 2 to the power of 11 to the power of 2 minus 1. Now 1 is the same thing as 1 squared, So now I have 2 to the power of 11 to the power of 2 minus 1 squared. Now the reason I did that and rewrote 1 as 1 squared is because now I can use the property a squared minus b squared is equal to a plus b times a minus b. So just to clarify, a is 2 to the power of 11 and b is 1. So now I get 2 to the power of 11 plus 1 times 2 to the power of 11 minus 1. Now what is 2 to the power of 11? Well, 2 to the power of 9 is 512. 2 to the power of 10 is going to be double of 2 to the power of 9, which is double of 512, which is 1024. So 2 to the power of 11 is double of 1024, which is 2048. So now I get 2048 plus 1 times 2048 minus 1. Now 2048 plus 1 is 2049, and 2048 minus 1 is 2047. So I get 2049 times 2047. And now, a simpler way of multiplying this, rather than the usual method of this way takes way too long. So a much easier route is to rewrite this as 2000 plus 49 times 2000 plus 47. Now from here, I can simply distribute. So I have 2000 times 2000, which is 2000 squared, plus 2000 times 47, plus 49 times 2000, plus 49 times 47. Now 2000 squared is going to be 4 million, plus 47 times 2000 is 94,000, plus 49 times 2000 is 98,000, and finally 49 times 47 is 2,303. So now, by adding all these up, I get 4,194,000, because 94,000 plus 98,000 is 194,000, and then I have to add in the 2,303, so now I get 303 at the end.